Myself, Sheikh Shafia Sultana. Today, my seminar topic is registers. Introduction. A shift register is a group of flip-flops connected in series to store and shift multiple bits of data either left or right with clock pulses. The register that shifts the bits to the left is called shift left register. The register that will shift the bits to the right is called shift right register. What are registers? In sequential logic design, a register is a group of flip-flops that work together to temporarily store and manipulate binary data. It is a sequential circuit that can store multiple bits of data, with each flip-flop holding a single bit. Registers are fundamental building blocks in digital systems. For tasks like data transfer and arithmetic operations, these are registers. Key characteristics. Composition. A register is made up of n flip-flops to store n bit of data. And next one, clock. All flip-flops within a single register share a common clock signal, ensuring they operate in sync. And next one, data storage. Register can store data that is located either seriously one bit at a time or in parallel, all bit at once. And next one, data access. Stored data can be retrieved from the register at its output. And last one, control of key characteristics of control. A load signal is often used to control when data is written input the register at the clock edge. When the load signal is low, the register of its current data is low. Based on the data loaded and retrieval from the register, the registers are classified into four types. CISO. CISO means serial in serial. SIPO. SIPO means serial in parallel. PISO. PISO means parallel in serial. PIPO. Parallel in parallel out. There are four types of registers. Now we have to discuss buffer register. A buffer register in digital electronics is a storage unit that holds binary data built using a series of D flip-flops, with each flip-flop storing one bit. Data is loaded into a buffer register at each clock tick, with outputs matching input bits at each leading clock edge. Its primary function is to act as a temporary storage area for data being transferred between devices or components, helping to match the different speeds of faster and slower devices. These are buffer registers. Now we have to see the buffer register of the diagram, and there are four types of registers are there, A, B, C, D, and the output is A, B, C, D, and they have to connect DA, QA is the first box, flip-flop A, and flip-flop B, DB, QB, and flip-flop C, DC, QC, and the last one D flip-flop, DD, QD is there. And they are connected, their flip-flops are connected in last CP is there, and it is a control patch. And they have to connect the DA is A input, DB is B output, DC is C input, DD is D. Then we have two CP is there are four flip-flops are connected in CP clock pulse. And these are called buffer registers. Controlled buffer register. Buffer registers lack control over inputs, causing uncontrolled outputs. To fix this, controlled buffer registers are used. In this design, tri-state switches are used to control the operation of loading and or retrieval of the data to or from the buffer registers. Here one has to pull the control line of blue line low in order to store the data into the register, while control line red line should be made low to read the data. These are control buffer registers. Here 4-bit control buffer register is there flip-flop to 4 flip-flops system. They have clock pulse is connected in the 4 bits, and their outputs is B1, B2, B3, B4, and the inputs is Q1, Q2, Q3, Q4. They are the control buffer register of 4 bits. Shift right registers is there. Now we have to discuss the register that transfer or shifts input data rightwards is called the shift right register. When the rising or falling clock edge arrives, then the stored bits shift forward according to the 1 bit position per clockwise. Data is entered into the register from the left side and the data is retrieved from the right side. There are four flip-flops system A, B, C. They are connected D in, and there are two connected line with four flip-flops are there. And last one D is output is D out. And they have we flip-flops are connected in CP flip-flops. And CP means clock pulse. Clock pulse. When the rising or falling clock edge arrives, then the stored bits shift rightward according to the 1 bit position per clock pulse. Shift left register. The register that transfers or shifts input data leftward is called the shift left register. When the rising or falling clock edge arrives, then the stored bits shift leftward according to the 1 bit position per clock pulse. Data is entered into the register from the right side and the data is retrieved from the left side. They have four flip-flops are there and they have two serial data outputs is D out, serial data input is D in. They have to connected in CP. CP means clock pulse. 1 bit position clock per clock pulse the how to data is entered into the register from the right side and the data is retrieved from the left side. Now we have two, they are called as shift left register is there. Bidirectional shift register. This type of register allows shifting of data either to the left or to the right. It can be implemented by using logic gate circuitry that enables the transfer of data from one stage to the next stage, to the right or to the left. Depending on the level of a control line, the right or left is a control unit signal, which allows data shifting either towards right or towards left. The right or left is the control input signal is low. The data in the register shifts towards the left. The right or left is the control input signal is high. Then the register shifts towards the right. And it can be implemented by using logic gate that enables the transfer of data from one state to the next state, to the right or to the left, depending on the level of a control line. These are called as this one type of registers allowing shifting of data either to the left or either to the right. Countries. There are four bits are there. A, B, C, D. There are flip-flops are and right or left. Serial data for right shift and the serial data for left shift. They are connected in CP. CP means clock pulse. They have so many gates are there and they have to connected in flip-flops. Now we have to see the SISO register. SISO means serial in serial out. A serial in serial out shift register accepts data 1 bit at a time through a single input line and the outputs data serial. Data enters and leaves 1 bit at a time in a serial sequence, typically made of multiple D flip-flops, connected in series and synchronized by a common clock. And they have four flip-flops is there. Serial input is a D flip-flop and serial output is 0 and they are connected in clock pulse. They have to input the D is input and the Q is the output. D and the serial inputs are connected in the line wise of flip flops is there and data enters the leaves 1 bit at a time in serial sequence, typically made of multiple D flip flops connected in series by a common clock pulse and it is a data 1 bit at a time through a single input line and output data is serial and these are called as a serial in and serial out registers. SIPO register. A serial in parallel out. These are SIPO register. Shift register accepts data 1 bit at a time through a single input line and the outputs data parallelly through multiple lines. Data is input 1 bit at a time and outputs are stored between parallel. There are four flip-flops is there and they are connected in clock pulse and they have two serial input is D and the Qs are connected in parallel output and they have to connect a clock and we have to see the clear inputs are there and data inputs 1 bit at a time and the output are stored bits in parallel is there. These are through a single input line and outputs data parallelly through multiple lines are there. These are SIPO register. PISO registers. PISO registers are parallel in serial out. Shift register accept data multiple bits at a time through multiple inputs lines and output data serially through a signal. And there are four flip-flops is there and they are connected in parallel inputs, and the flip-flops are connected in serial output, and it is called as serial input also. And they have accept data multiple bits at a time through multiple inputs line, and the outputs data serially connected in pulse, and they have to connected to the parallel input, and they have to connected also serial input also, and they have to shift the accept data multiple bits at a time. They have to connect a shift to the serial output. Universal shift register. A universal shift register is an n-bit register that supports both left and right shifting as well as parallel unloading. Using n flip-flops and n multiplexer with shared select lines to the control data flow. It combines the features of bidirectional and unidirectional shift registers. Enabling wastage data manipulation, shift left or shift right, parallel load and hold. They have S0 and S1 operations is there, 0 0 and its come operation is hold, and 0 1 they are the operation shift left, and 1 0 they have to operation shift left, and 1 1 they have to the parallel load is there. These are universal shift registers. This diagram shows the universal shift registers is there. They have so many serial inputs are there and serial outputs for left shift, serial inputs for right shift. They have to connect a parallel inputs bits and they have to connect a parallel output bits. They have to counters, they have to connect the clock pulse. Thank you for giving me this opportunity to